Welcome everybody to a new live session of programming game development. And today we are going to do a different task. So we are going to build a new game from scratch. It's the also the well-known MineSweeper, Minefinder. So in the MineSweeper is the classical game. So what we do in this session is we will code the logic. So instead of doing the graphical aspects, we will code only those classes and the package that will provide all the logic for the graphical interface that we can code tomorrow. So it's a bit different. So as I said, we are going to focus on text only. So I have created here. Okay, let me instructions. Okay, this is the classical Minesweeper. So we will call it Minefinder. So this is the classical game that it was released with Windows. So we will try to do the same or the logic behind this game, and we will use just the console, so text only. So the first that we have an empty project with an empty source. So let me create a new package. So it could be Minefinder. Okay, I agree. Minefinder, it will be the package. So let's create a new a new class. So it will be the same. So it's the Minefinder is the name of the class. So here we will use this one just to let's move this to the right. Here we will use this is the main code. So let's add the public static void main. Okay, and we'll start from the start from scratch. So let's run this one. So run as Java application. So here is the output. Let me increase the font size. So this is the output. So let's change the title just to my mine finder. Okay. So this is the code. This is the game that we are going to do today. So let's start with what we need. So I was thinking about what we'll need. So mainly, if you see, let's leave it here. So what we need is just an array, just to keep the data. So what we need to do first is to create a map. So let's create a map. So in order to create a map, so let's say that I usually use a logic. Yes, it could be a logic. So let's create a new class here. That is better. That it could be the logic, the game logic. So let's call it logic. So here in the main finder, so what we can have is to have uh, a new instance of this one. So let's create a new instance. And what we will want to do is just to create a new map. So yes, it could be new game or new map, and we will provide the width and the height. So we can provide the number of rows and columns. So let me say, for example, in order to print it, so let's say that is 20 and 10. Okay. Okay. So let's implement this new map. So we are going to create it. So okay, so this is the empty builder. So builder has nothing here. We will use later tomorrow for another topic. So let's create. So we need to hold information about the map. So where we can store that. So I think that the best way to hold that is just to keep an array. So this is, we know the size of it. So let's say that we can hold here a private right now it could be wherever. So let's say that is a char and we will change it later. It could be an array of arrays, or it could be just an array. So this is the map. So the new map is, for example, is the number of rows. So it's yes, number of rows and number of columns. So let's change here because I want 10 rows and 20 columns. So what we will do here is just to initialize the map. Is equal to new char uh, rows times calls. Okay, so this is the new map. So whenever we call this one, we will just initialize the game, the map. So what we will need also is something just to a method to draw the map. So let's add a new method here. So let's check that say so that we can here logic and draw a map. Okay, so we will implement that one. So draw map. So it does not need anything because it has the logic knows all the details. So here that's why we don't need any argument. So in order to draw it, we are going to use the console. So let's say instead of using system output, I will use string builder equal new string builder is faster. Okay, so what we will do is that we need just to get all the charts from this map and just to draw it here in the console. So let's we need to draw line by line. So what we'll use is the number of row, the number of columns. So in order to split the map, so this will be 4. This could be the row for the row starts at 0, while row is lower than the number of rows. Okay, we need to store this in a local in a property. Just increase the row. Okay, this is just to draw the rows. So we need this property. So just create it. So we will create both rows and columns. This is the number of rows and the number of columns. So we will need to store here locally this dot calls equals calls. Okay, so we have it here, so we can access later. So I can access here because I have saved the value that I have passed here. So okay, spelling. So for each row, I want to uh, draw the row. So we will add some code here, and I want because this is just a console. I need to add what we call, let's say, add here a new private char new line. This is the new line code. Is called system line separator. So we will use this one. Okay, what's the problem here? Change the okay, so let's change. Okay, new line. So we will add a new line, a carrier return after each line. So what code we will need to add here? Okay, we will need to add all the charts in one line. So we need to add here not all the map, only part of it. So dot I don't know if there is some method here. No. Let's check another way. If we have arrays to string. Okay, this is to print all the lines. So it's not what I need. Okay. Okay. Just for the moment, let's add a double for loop. So I'm print it each position at each time. So this will be the column 0, while column is lower than the number of columns, increase the number of columns. So here we will draw the map position that it will be column plus row times rows. Okay. Okay, let's check if there is any error. Okay, nothing is drawn. Let me check this map. Okay, yes. I need to draw something, so we need to output in this one. So this is just to string. So we need this is just to draw the string builder. So okay, as you can see, it seems that it's empty, but it's not. What's happening right now is that if we do not initialize the chars, the default value is 0. So by default we get 0. So this is why it's nothing is drawn here, because all of them get the 0. Okay. So here, depending on the chart or the type, in the future we will need to add different behavior. So let's say just to do a quick check that we add here. Let's add here, for example, a plus sign. Okay. So you will get 3, 6, 9, 10, 10 columns. So it's what we requested here. And this is 20, the width is 20. So if we change here, for example, if we say, okay, only 8 and 20, 25, so it will draw the new map. Okay. Let me Okay, so with this code we have more or less an empty map. So this is an empty map without anything drawn. So in order uh, to draw the cells, so the position, the mines or whatever, we need to differentiate different situations. So we need to know if it's hidden. So if it's hidden, we don't want to draw anything. If it's revealed, we want to show how many mines are around of it. So and later in advanced options for the hidden, you can mark them as unknown or just a mine or whatever. So the first, sorry, and the instead of have a map of charts that it's possible, so we can have different codes for each different value. So it's better if we create a class. So let's create a class, and this class will be the cell. Okay, this is a cell. So cell will have different properties. So one of them it will be if it has a mine or is empty. So we will define here different properties for the cell. Okay, and the logic it can be it. So instead of having here an array of charts, we will create an array of cells. Okay. So we have changed instead of having charts, we have now have an struct. So we have a class that is called cell. So by default, for example, we can set the default state. So let's say that we have here a private property. So we can have here just say if is mine. So boolean is mine is a mine. It's mine. So if not, so by default it could be that this is mine is false. So by default they are not mines. Okay, this is an option. So we can initialize here. So by default is mine is false. So even if we do not add this code, it will be false. Okay, and when we draw it, instead of adding this code, so let's change it. Okay, we will use this cell the same, but we will call, for example, the draw option, draw. Okay, this map, sorry, this map. So we are calling the map. So let's say 2 steps. It will be clear. Our cell, in this case, for this row and this column, is this one. So this is the cell. And what we want to do is just to draw the cell. So drawing the cell, it knows what to do, how to do it. So let's create the draw cell here. So here we can have a small code saying, okay, so I'm going to return a string or a chart. So if this is mine, so imagine that is a mine. So let's um, okay, let's add here. Sorry, no, not this way. So this is a string. This is the output. Uh, mhm, yes. So this is the output. So by default, if it's a mine, output will be, for example, a star. A star is a mine. Else, so if it's empty, the output it will be. Mm, so let's say a dot. It could be a dot just to be more or less clear, or maybe later we will prefer just to draw only empty spaces. Okay, I will return the output value. So let's do it again. Null pointer, something it's wrong. Null pointer, line 28. Why? Seal is 8. Y cell is empty. Okay, we have initialized here. Okay, we have created uh, an array. An array, but they are empty. Okay, cells. It's an array of empty. Empty. It's prepared for cells, but they are all null. So we need to initialize the map. So when we create a new map, we create an empty one. So let's create here some code just to, it's the same code as here. So let me check. Still is 28 is null. Okay, it's not this code because this code was working. The map is initialized, but cell line 28 is strange. This map is here, is new. Let me add here some code and let's debug it. It's not clear what's happening. Okay, the map. So we have this, we have the map, and the map has a lot of values, but all the cells that you can see here are null, 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 null. So when we uh, just execute this line, cell is null because we have not created, initialized the cells. So this is an array of empty cells. So let's do a for loop. So, mhm. So and it's more or less the same. It's equal to new cell. Okay, so we have just initialized all of them. So and we get here the output. We get the map. So it's a map with empty. So let's add some code in order to create the mines. So when we create a new map, we need to add, we need to know the size, and we need to know the number of mines inside of that one. So let's say that we have here and the number of mines. So the number of mines. Okay, so here we will need to add that value. So let's say that we add, for example, 10, 10 mines. And here when we initialize, we need to add here in some positions, in random positions, we will need to add some, instead of this standard one that is created, is mine is false. We need to create one with saying, okay, let's add here public. Okay, I think I will add the getters and setters. So let's add here. Just a standard code for getters and setters. So we will add here source, getters and setters. Yes, select all. Okay. And the draw functions. And this is only used for text and drawing, so we will not use them when we have a graphical environment. So okay, so here what we need is just to be sure that we so to be sure that we add the number that we need. So no more than this number of mines and no less than them. So one thing that it could be done is just to select random. So let's move this code out of here. So let's refactor and extract this method, and we can call this create empty map. Okay, so What it's thinking? Okay. So this creates an empty map. So maybe we need to return this as. So let's return this as the parameter. So here it's our map, local map. Okay, so in this, and we will return it, return the map. Okay, so with these two dimensions, with the width and the height, so number of rows and columns, we create here a new map of cells, and we initialize the each cell to an empty, so a default cell, and we will return that to the standard the property here that we will use in the logic. So here we create an empty map, and what we need right now is to update it, is to fill fill with mines and the number of mines. Okay, so we will use this one. So maybe here we need to, okay, we can use this one. Let's add here the map. So let's add the map. Okay, and just fill with mines the map. So let's create this new method. Okay. So here this method receive a map, a already initialized map, and we need to just randomly create this number of mines. So the first thing that we need to know is the size of the map. So it's easy. So this is the map length. We don't care if it's this is a linear map, so we don't care that in order to draw it we use two dimensions. So for us it's just a linear one. So in order to initialize it, so we will use it, we will manage. So let's create a random. It's random. It's equals to new random. So this is a random generator. So what we need is just to we will need an integer. This will be the position. So it will be a random next integer. So it's an integer, and the maximum is size. So let's return a random value between 0 and size -1. So this will be the position that we will initialize map this position. This is a cell, so is mine. Okay, I want to set it, so is set mine. Set mine true. Okay, so we will set that this position is a mine. So what we need is just to repeat this and the number of the same times that we need to add the number of mines. So this is an index, for example, 0, y index is lower than number of mines, increase it. So repeat these codes so many times, the times needed. Okay, there is only one issue here, is that we can generate here a repeated value. So in order to avoid that, we need to check that the we need to check that the map position is not already a mine. So if is mine is equal to false, so if it's not a mine, it's not yet a mine, Okay, then yes. And this loop is not enough because we need to decrease in this case the index. So let's change it for another one. So int I equal to 0. So while e, this is the number of mines, is lower than what we need. So let's rename this one. It is located what we have already put in the system. So already set the mines. I don't know how to say it. So already assigned it. So already changed. So already assign it. Set. So it's yes, it's the number of mines. So we have start with the number of mines in the game is 0. So while the number of mines in the game in the map is lower than the number of mines so, that we want, so this is the desired number of mines, just get a random value, check that it's not already a mine, and uh, switch to a mine, and only in this case you can increase it. Okay, so with this code we have, when we create a new map, we initialize the height, the width and the height. We create the empty one and then we fill it with mines with this code and this code. So this code is just to do this task. Of course, we will have the draw one. So this is the draw map is like this one. It's not needed for the graphical version. So only these ones. Okay, so I think it's all. Let's check that we get. Okay, no logic. Number 37. Okay, if map push is mine. Hmm, we get this map. This map has been already initialized. Create empty map. So all of them has been new cell, new cell. So we have, and why when we try to access here to the map, that is this map, create empty map, creates a map and returns the map. So here the map has all the values. We pass that map is here, check the map, why is mine is not two options, so we are let's check here, or we are trying strange. So when we reach here, the map must be already initialized. So okay, we have here cells with this mine is false. So we have between 0 and the maximum number is okay, almost okay. We have here some of them are null. Why there are null values here? I think there is an issue with the loops. So we have initialized only 80. 80, so we have, okay, no, there is a mistake with the loop in some of the loops. So let's stop. When we initialize the empty map, the row, number of column, number of columns, call. So this is the row. So we start with row number 0 and column between 0 and maximum calls. And then we move to row number 1. Row number 1, it's for, okay, row number 1 is this is calls. Okay, this is an error here. This is calls. So maybe there is also a mistake here, and this is calls. Okay, let's run again. Okay, and here we have the map. So this is what we will call the reveal map. So this is uh, the real map. So this is the map with all the values. So this will be hidden, but right now we will see all the map. So and this is what we need just to create the map. Okay. So I think the map is created, so we will improve in this cell option just to say, okay, let's say that we have, I need to get, okay, this private boolean hidden, so by default must be true, so this hidden, it will be true, so this means that by default they are hidden till the user reveals it, so clicks it. So let me add here some code, getters and setters, select all, create. Okay, okay, okay. So we have here the options. So when we draw it, the code that draws the map needs to know uh, depending if the cell is hidden. If is hidden, needs to draw something. If it's not, if it's hidden, we will need to draw a standard value, maybe a static value, cell. I don't know what. Okay, it will be okay. It will be provided by itself. So I think the logic must be the cell can provide the logic. Hello, señorita Lara. Welcome. And hey, and Rabbi Twitch guy. Uh, mm, so we can leave that the cell knows what to provide depending if it's hidden or not. Just this is just it's from scratch. It's a my own game engine, and before doing any game, so let's show you, for example, secret. That is secret. Secret has two versions, so let's run this one. Uh-huh. Launching secret 90%, 100%. So yes, 3D must wait because I have started too many times with 3D using using OpenGL, and when you focus on 3D, you spend too much time in graphics and 3D, and you are not focused on game development. So there are a lot of stuff in game engines apart from the graphical interface. So this is the secret. Okay, it's time over. So this is a version of graphical version, but this started with a very basic version that is here, that is called monolithic. So as you can see here in the console, It is a text and it works the same way. So the logic is the same. So both the version in the console is the same as what we have in in the graphical part. So it uses the same. So it's just drawing or doing a lot of different things. But this type of games, that these simple games, it could be managed or created just with text. So in console, so a lot of them you can represent. For example, with the mine finder, we can use the plus or the stars just to represent different elements. Later, of course, we will need good, nice 2D or 3D assets just to represent that. So it's easy to change if you are a good 2D or 3D artist. But it takes a lot of time also to make good assets or find it or get someone that can collaborate just to create them. But more or less the logic I prefer to start for these ones. Just doing what we are doing today is just uh, the version, the text version, and when it works, when it's more or less it's fine. So you have think about all the steps. Uh, I think the hardest part is this part is to understand or to know where to store the data. So when it's clear what you need to save, which data are you going to save when you create a new game, what part needs to be restarted, or when you have this part clear, it's very easy just to add some graphicals components or do whatever. So if you are a better 2D or 3D artist, it's great. So but this is more or less even the very complex games are very easy. So it's very easy. They all start with some simple logic like this one. So it's with simple rules, just create map. So okay, create map. So create an empty map and fill it with mines. Okay, bye bye, señorita Lara. And it's easy to you need to start, so I prefer to start at very low level, so just because they start to be very complex later, very complex. It's very easy just to get very complex. So from my point of view, I think that you can do big things if they are easy to change or easy to be managed. So even it's very important to start with things. Yes, to do it. What we are trying to do here is just to sometimes you work from the main. So instead of doing a lot of code, you just start with what the output. So maybe you start saying, okay, I want to run a game. So new game, and you start to do the code below. So here, this code is mm, is more or less because I use this one later when this game engine is based on events. So later, the main loop of the engine, we will call different events. So in order to draw, it will call things like new map to start the game, or later it will start just to call saying, okay, the mouse is at this position is column and row, whatever. So, okay, what happens when user clicks on this position? So the logic behind is the same for a text-based game or graphical one. So you just need to translate the input from the mouse. Here maybe we will use, I have not yet reached to that part, but if you have a graphical one, usually use a pointer or the mouse. Maybe here we will use, maybe we'll need to provide the column and the row. So we will need to provide both values here in the console, just saying, okay, I want to click on column 6 and row 5, just to do more or less the same logic and try to do the same using a text-based game. So if it's working tomorrow, I will start all day to move this to a graphical interface. So we will start as we did with the secret. We have this is the text version, and this is the graphical one using the engine. So we will do it tomorrow if we finish the text version today. So let's continue. So where we are, I think, let me run it again. So, okay, so we have the Unhidden, the reveal map. So this is what it will use internally. Okay, we were trying to check if who must manage in order to draw it. Um, Usually, the drawing system does not know anything about the logic. So the drawing system just draw whatever it gets from other components. So maybe in this case, I think that this logic must not be here. So I think it's better to leave as it was. So I prefer to have a drawing system very simple, because for me the drawing system only needs to know to draw a picture, to draw some text, or simple things, simple stuff. So in this case, we have a draw map function that is only just accessing to the data and just calling the draw. Instead of draw, it could be just to get the picture. So for example, it could be, if it's a graphical one, it could be, okay, we are, let me show here better. If we are at this position, first row, first column, so which picture I need to draw at this position? So okay, it will be a hidden. This is the hidden picture. So if it's a mine, it will and the cell could return the mine itself. So a different picture. So if you return an enum type or whatever, the draw system needs to manage that. So it's very difficult to have a drawing system that could fit in different games. So right now the drawing system is using for Hangman, for Secret, for the GUI, and different ones. So it must be very simple. It's only focus on drawing things. So I think that's the reason why when we call cell draw, it's the cell itself what needs to have the logic here. So before drawing this information, before drawing the unrevealed or unhidden information, it needs to check if it is hidden. Because if it's hidden, what we need to return is just the hidden chart in this case, so it's the hidden picture. So if it's hidden, so let's say, okay, I don't know if I have, I think if I provide some, let me find if I can get some ASCII values for ASCII charts. Something, I think that when you draw something that cannot be drawn, it provides a square. So I think it was. Let me try to draw something strange here. For example, less than 32, so 31. Okay, let's try 31. Okay, 31. Okay, it doesn't like it. Mhm. No, this one no. So this one plus a char and char code 31. Okay, if it's hidden, we are going to show a not printable ASCII char. So I expect something strange here. Else, so if it's revealed, so in this case, okay, depending if it's a mine, okay, we will, okay, later instead of an empty one, we will show here the number of mines that are surrounded this one. So by default, we have said that all of them are hidden. So I expect this strange code to be drawn for the full map. Okay, okay. It's the. I think I can do it bigger. And this is the ASCII chart that is shown when it has no. It's not printable. So let me find. Okay, I think at the moment. Don't know if I have another option here when looking at the keyboard. Okay, so let's this one. Let me try with squares. Let me try if we draw this one. Maybe it's better because it seems like hmm, okay, not too much. And what I have here, something that okay, the okay, I have this one. Okay, I think I prefer this one. So this will be the standard cell. Okay, this is a cell that has not been revealed, so it's already hidden. So this is our hidden map. This is the hidden map. If we unhide uh, any of them, we will get the the value. So what we need also is just we cannot provide this dot. So we need if there is a mine closer to it, when we reveal that cell, it must show the value. So where is it created? Is here. So we have created an empty map. We have filled it with mines. So let's at the moment to comment this one because I want to show the unhidden map. Okay, so we want to the values closer to the mines. They must be 1 1 1 because it's the here as you can see when you click on each of the cells, if they can be empty, so this is more or less like 0, so we can represent with a dot, but this means 0 0 surrounding, so this is 0. And if there is a mine closer, it's 1, or depending on the number you get 1 2 or whatever. So we need to add these numbers to the map, to the cell. So here instead the options is that if it's mine, it will be represented by this as the code, so start. If it's hidden, of course, it's this one. So hidden is by default all of them are hidden. And if it's not a mine, it will be an integer with the surrounding su it's too long. Let me check the spelling. Let's see, surrounding. I think be a smaller name, say closer, nearby mines. Or Okay, nearby mines, maybe it's a good name. Okay, it could be a name, at least it's a name. So nearby names. So let's add here the getters and setters. So we need to add that one. Okay, select all here. Okay, so here we will use this code, this in getters and setters, in order to fill them up. So we need to check for all of them. So at the moment we have uh, created an empty map, we have filled it with the number of mines that we have here, and we need to do another step, that is add the surrounded, how to say it, so add surrounded, mm, surrounding mines. So we will use the map itself, and it's enough. Okay, so with this one I'm going to add the code here. Let's implement this one. Okay, so what to do? I think it will be okay, it's mhm. There are two ways. Maybe it's better to use the this one and it here. Hmm. There are two options. Whenever we add a mine, we can just call all the surrounding mines and just increase the number of mines, the surrounding mines. So in this case, for example, when we add here, okay, let's add. Okay, why I cannot increase the font size? So when we add this mine, this will be changed to 1, here 1. When we add this one, it will be increased another 1, so this will be 2 and this will be 2. So one option is to use the same method that we use to fill with mines, and then add add the code to the surroundings. So let's add that way, that is easier instead of. So if map is mine is false, so we add. So okay, so here it will be increase increase. um, I think it's nearby. Increase nearby mines for all the surroundings. So this is the position. Okay, so this is not needed. So create method. Okay, what we want to do is just, let me add here some little graphs. So imagine that we have this map. Mm, So whenever, and this is the position of this, we have set here this as mine. So we have selected that this is the position. It's mine. And what we want to do is just all the surrounding ones to increase to 1. So this will be the output. So this is the output. It's what we want with this method. Just we provide the position is this one, and we want to get all the surrounding cells to be increased by 1. Of course, if they are not are. So let's add another one here. Okay, no, later. only if they are not, of course, are already a mine. If not, it makes no sense. So let's start. So the first thing that we need to know, it's very easy. So we have this one position, but we don't have access to the map. So we need the map. So the map, we need the map. Okay. So the easiest ones are the left and right. So they are very easy because it's just this map position -1 dot near get nearby. I think I will add a new one instead of saying okay, set nearby it's equals to the same. So I will need just to get the value and set the value to the previous one plus one. So I think I just create a new one here instead of getting it and setting it to one. So I can say create a new one that is increase nearby mines. So this will increase just by one. So this nearby it will be plus one. So nearby by default is 0, so we can add here this nearby mines equals 0, so by default there are no mines closer. Okay, so it's easy but not very easy to say okay, this is the position 1. It's easy if you are here, but imagine that the mine is here, so only these ones will be modified. So we don't want to increase this one because this is the next position in the array. So you after this one you continue here because it's the same array. So not so easy. So what we need to know is just if the position is on one of the edges or not. So let's check. There are a lot of different situations. So okay, so we want if. So let's start with left. So left is in this cell, sorry, this map position -1 dot increase. Okay, this will be the code, the easy code, but it's not so easy. We want to do this one only if it's not the first column. So always except, for example, if it's at this position, because we don't want to update the left one. So we want to more than left, we want to know if there is the is first column. Okay, so we need to know if it's the first column. So we have the index, so position is the index, and we know how many cells are in the map. So it's the number of columns. So if we divide this one by columns, by these dot calls, so if we add 0 divided by, for example, in this case is 25, so 0 divided by 25 is 0, and 25 divided by 25 is 1, and the remainder is 0. Okay, so this is the remaining of the division. So what we want to do is to get this is the column, so the column is in this one. So if column is 0, so okay, so I think if it's greater than 0, so if we are not on the left edge, then okay, increase the left one. Okay, this is for the first column. Mhm. Okay, let's add this way because we have a lot of code here. So instead of column, I think that okay, the same for the last column. So if column, okay, I think if it's not okay, if it's not 0, if it's 1 or greater, we can okay. And if we are not at the last columns, or columns goes if it's 25 columns, the numbers are between 0 and 25. So if it's these columns minus 1, so if it's not the last column, so 24, then we can modify the right one, and the position plus 1. Okay. So this is just to check. I think that I'm going to use them a lot of times. So let's add some booleans here. Boolean is first column. This is if column equals to 0. So if columns is 0, is the first column. So the same for the last column. Boolean is last column is column equals to the number of columns minus 1. Okay, so then the code is easier. If not is first column, okay, there is a misspelling here. Okay, if not is the last column, is last column. Okay, so if it's not the first column, update the left one. If it's not the last column, update the right one. So position minus 1, position plus 1. Okay, so we have these two options, these two ones. So we have these options, and let's add here some just to show. So let's say that is this one. Okay, so we can have this option, this one, and this one, so we take care of all of these different behaviors. So what we need to do is the same, but imagine that we are, in order to update uh, up and below, we need to know if we are in this new situation. So imagine that we are in these situations. So in order to update the upper row, in these situations, there is nothing to update. And the same in this situation. So if we are the last column, there is nothing to update below. So this is the column, and we will need the same for the row. So at which row we are. So this is the position divided by these dot calls. So in this case, we have 25. This is 25 cells. So if you divide, for example, we are 50, 50 divided by 25, 25, it's 2. So we are positioned at this position. We are at position 0 of row number 2. So if we are, for example, we are a 3, 3 divided by 25, it's 0 because this is an integer division. So the row will be 0. So this provides the row value. So its first row, it's when row is 0. When row it's okay, it's last row. So we have here the same, we have new booleans for the same. So this is left and right, so this is this one, and let's start, this is left and right. So let's start with the upper row. So only if we are not at the top, if it's not the first row, so only if we are not at first row, only in these situations we will update the upper row. Okay, and the lower, the bottom, upper, lower row, it will be only updated if not, it's not the last row. Okay, is last. So this condition is needed. Okay, so if it's not the first row, we need to update the first row. Okay, so let's imagine that we are in this situation. So which positions? It depends. If we are the first column, we will update only these two ones. If we are the last columns, only these two ones. So we need to know if at which position we are. So if uh, always we will update the position just uh, on top of us. So in the same position, but one line. So always the position above us. So this is the position minus the one row. One row is the number of columns, so 25. So always this is just up of our position. So, and for the others, we will use more or less this code. So if it's not the first column, so for example here or here, we will update the position -1 and of course one row above. So we need to subtract here and subtract here. If we are not at the last column, we will update a position +1, but on the previous row. So just subtract one column. And this is the same code here for the last row, but instead of subtracting, we will need to add one row. Okay. So not sure if the code is right, so we need to check it. So okay, let's do the first try. So let's try it. Okay, something is not working. Okay, I think it's in the drawing. Okay, the drawing, if it's a mine, is this one. If not, I want to print the nearby mines. So if this nearby mines equal to 0, then output as usually just an empty one. If not, I want to output the number of nearby mines. What's happened here? Nearby change type of output. Okay, this is an integer. String dot value of. Okay, I think it will work. Okay, so we have a lot of code here. A lot of, let's check, and this starts, so let's increase it and check that it's working as expected. So and this is stars, there's rounded 1 1 1 1, and this one has 2 because this one and this one, so these are affected by this one and this one, so that's why instead of 1 is 2 and 2. Okay, these are all 1 and 1. Yes, this 3 is from this one, and these 3 ones is here. 2, okay, it's working, it seems. 3 ones, 2. Okay, this 2, where is, okay, is from here. So it seems that mm, this one from here, 1. This is 1 and 1, but it's 2 because it's 2 times, and from the above is 3. Okay, it seems it's working. So I think that let's run again and have a different one. So for example, here we have a mine on the top left corner, so we have not updated this one. So we have not updated from the left. This is correct. Hmm. Okay, I think it's creating a correct map. Let's run again. Just check it. I want to check mine on the. Okay, this is a good one. So if the code was incorrectly, it will increase this one because this position -1 is on the previous row. So it's working. So it's not updating from the left to the right. So it's not doing it. So this is the code standard. This is on the top row, on the bottom row. So we have mines all. And instead of drawing a 0, what we are just is drawing a dot for the empty ones. So later we will need to add a lot of code here just to clear the areas, because if you remember the game, whenever you click on an empty one, all it's clear, all the information is clear, the path is clear. So this is another method that we will need to add. So I think it's working. So we have a map, we have the map with a reveal map. So let's try adding more mines. So let's add 25. Okay, with 25, we have not get more than 3. Mhm. 3 here. Let's try again. I want to see some 4 or 5. No, let's increase it. 35. Okay, okay, we have a 4 here. 1, 2, 3, 4. So this is a 4, another 4 here. Okay. Mhm. Okay, I think it's working. So we get what's expected. So if there is any issue, I see here too many, too many ones. So these 3 ones belongs to this star. Okay, this to this one, this one, and this one, and this 2 is from the below. Okay, 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 okay. So we can, with this one, we can create whatever we want. So we can create large maps with, it's very easy, just increase it and create bigger and bigger maps. So just for the difficulty, you can increase the map size, or you can increase the number of mines. So here we have 5, 3, and 2, 5. It's okay. Okay, I think it's working. Okay, nice, nice. We have it. Okay, what's next? What's next? So we have the map. So if we return to the hidden, by default is true, so we will get the same map, but all hidden, a hidden map. So what we need next is to provide information. So we need some way we go back to the main program. So this is the main game. So here is the we have created the logic, and we have created a new game. So we need to create here a loop. So let's create an infinite loop by now. Okay, so this is an infinite loop, just updating it. Okay, we will have an issue here. Okay, because okay, and we need to here we don't have the mouse, so we will use the system scanner in equal as I think it's new scanner system in util scanner. Okay, so here what we want is just to the first thing that we want is just to draw the map, and just to say enter coordinates. So and we will read in dot. Okay, we can read a new line, or we can read the numbers. So let's start with in dot read. Okay, what's happened? In okay, next line. I think it's what is it? And next and next. If I remember. Okay, next line. Okay, next line waits till you press enter. So we will click next line. So next line it will be two values with space or a comma between them. Let's use a comma, whatever. So whatever we want here. So this is the input. So this is the input. So this is just draw. This is our main loop. Just draw. Draw the map. This is the user input. The input. Let's split it. Just suppose that we use. Okay, let's do it with comma. And this will be an array of, okay, right now it will be two, the coordinates, it will be two strings. So, for example, the first one could be the row. So it could be the row, it's integer dot parse integer, and from the chords, the first one it will be the row comma column. This is the input that I want. And input the column in the same way, it's an integer parse int chords. Okay, Okay, with this one, we get the input, and we split the input in two values, in two strings, the row and column. We transform that string in an integer because we need an integer value. So we have the row and column that the user has added. So the first thing that we will do is just to call the game, the logic here, and we want to reveal that position. So okay, so we have the public ones. Okay, I mean this is a public method that we can call from the man finder, that is just create a new map. We have the draw maps, and here we need some ones just to say okay. I hate that public void unhide unhide or reveal. I don't say what to use. Reveal unhide. Okay, and unhide unhide, and we can say we have say the row and the column. Okay, so this is the method that will be called by here. So let's say that is unhide. Okay, row and column. Okay, so here row and column, and this what will do, what can it do? It's we need the position because this map it's a linear map, so the column is itself, and we need for each row we need to multiply by times the size of a column. So okay, so this is the cell selected by the user, and we want to set hidden to false. Well, I think that we can use a new one here that is just unhide. It's easier to read. Unhide. I need to add this one. It's like set hidden false. So it's public void unhide. It's just to say this hidden false. Okay, so this is selecting. Okay, I think it's all. I need to close it in dot close. Okay, what's claiming here? Leaking is never closed. Okay, it's never closed because it's and we need just to provide things like a way to just to finish instead of providing this value. So okay, if the number of chords, if chords length is below 2, the game ends. Okay. So else is a movement. Okay, so let's while is running. This is a boolean. Is running equal true. And we can say that if you do not enter two coordinates, it's the end of the game. So it's false. Okay, let's try it. Okay, so we have enter coordinates. So if I enter only one thing, it stops. Okay. Okay, let's add here a message just saying that game over. Okay, let's run again. So if I've entered, for example, game over. Okay, let's run again and let's start. So if I select row 1 comma 1, okay, here it's using the programming way that is starting the rows and the columns start with 0. So and the corner is 0 dot 0 just to reveal this one. Okay, so we have right now a way to a way to provide the coordinates. It's not the easiest one, so it's difficult. 0 dot 1, but it's a way to do it. Maybe we need to provide. Okay, I think that what we can do. Okay, so I suppose maybe in row one, position 2, there is a mine. No, not yet. Mm, 0, 3. Okay, a mine is there. Okay, so we next. It's very slow to play a game in this way, so let's reduce the size to 10 columns, 10 and only 5. So let's do that this way. Okay, no, it's must have it must be wider. So number of columns, let's say 20, and rows maybe with 7 it's enough. Okay, that has it's better. So let's say that is this way. So I can start with the corner and the topmost. Oh, okay, let's try with a strange value. So uh, it will return an error. It will be an error because we are trying to access a position that is not. So we need to check that condition. So we need to check that the position is lower than the size. So let's add that logic here. Okay, instead of hiding in height, and this is the position. So the position is this one. So let's do a check here if position is greater or equal than 0 and lower or equal lower or equal than. Okay, it's lower than the maximum size, so this map length, because we start with 0, so if there are 25 positions, the last one is 24, it's one less. So only in those situations, if there is a valid position, it's a valid uh, position is inside of the array. Let's only in those situations just follow it, try to unreveal. So okay, so if I add an incorrect value, it just ignore and draw again the map, so it's not taking care of my input. Let's try with a negative one. Okay, so this is the row. So let's say that we have 4 and this is a valid one. Strange, but it's a valid one because we are not checking individual numbers of the row and the column. We are checking the total number, the position, and not the column and the row itself. So if we have them here, rows and columns, I think it's better just to check them. So if column is greater or equal to 0 and column is lower or equal to this number of columns. Okay, so if we have lower, so it must pass this condition, and also it must pass the row condition, so it must be greater than 0 and it must be lower than this dot rows. Okay, only in those situations we will calculate the position and we will unhide, so it's better than this one. So that code will avoid any situation like this one. Okay, okay, okay. So we are taking care of the out of bounds options. So 0.0, and the last one in this case is we have the row. We have 7 rows, so the maximum row is 6, and we have 20 columns, so the maximum column is 19. So this is the bottom right corner. Okay, so it's correct. So one thing that we can do that it will increase the way, so we need to check if it's a mine. So we have just check a mine. We have selected a mine, so it's a game over. And this is the loss condition. And another thing is when we unhide a position that is an empty space, like in the game, uh, not only that position is clear, so it's all the surrounding that they have. I think it was okay, all the surrounding to the empty ones. So if the nearby is 0, all the surrounding must be revealed. Okay, so let's try to do that. So how to do that? So in the code here, the loop, the main loop is clear. So it's just do an endless loop, draw the map, get the user input, and here this is just to do the check. So this is the check. Here is when we try. So this is when we play. It's our what we are trying to do. So when we click, when we select from the logic to unhide one of the row or columns, it's correct. So it's but this unhide in the logic must do more tasks. So it's not only that we just unhide this current position. So we need to unhide this one and more positions. So how to do that? So what we can say if that only if this map position was what's that dot nearby. So get nearby means okay. This is a cell. Okay, if get nearby is it's equal to 0, so that means that it's an empty one. Okay, so get nearby by default, if you remember, we get the number of mines near. So if it's 0, that means that we are at this in the it has 0 by default. It's 0 if we do not have added anything. So so if it's 0, what I need is to just to clear more cells. So so this is clear, clear, closer or clear. I think it's Okay, I think it's clear. The this is a cross. I think it's only the upper left, right, up and down position. So it's clear, clear, closer, clear, closer. Okay, it's not. I think it's the all the positions. So it's clearing all of them. So it's the 9 positions. What they are clear. So it's clear, clear, square, clear. The 9 area, clear area 9 of this position, more or less. Yes, it's to clear the surroundings. It's clear the 9 positions. All so each empty one has 6, 8, or sorry, clear the 8 surrounding cells. So this 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 new method needs to do something like it's very close to the function that we had it before to increase the nearby mines. So this code was to increase them. So this code was just here increasing, but instead of increasing, what we need to do now is just to change to switch the the hidden value to false. So not sure if we can reuse it. So I can copy and paste, but okay, this here, what is doing is increase, and here what I want to do is unhide. Okay, I think that I will copy it right now because I need to add more stuff here because it's not so easy. So we check the position because if, for example, in this situation is the top left corner, we cannot reveal the previous line because there is no previous line or there is no previous column. So we need to do all of these checks. If it's first column, it's last column, so all of this must be done. And in these situations, instead of increase nearby mines, what I need to do is to switch the hidden. So this is dot unhide, I think is the new name. So it's unhide. So this is what is done to unhide the 8. So it's a 9 square, so 8 surrounding cells. So we want to unhide all the surrounding ones. But not only that, because any of these ones can be another empty one. So if when you have here, so imagine that you have this one here, and this one is empty. So when you are unhidden all the surrounding ones, you get another empty one. You need to do it again and again. But but not doing it back because if not, you will enter in an endless loop. So in a recursively loop, and you will fill the heap. So before unhide, what we need to check is that it was hidden. So only if it was hidden, so if it was hidden and it's an empty, we need to call again this one for each of them. So 8 times. So this code, let's do it with just one. So first of all, we need to check if this map was an empty one, so nearby, I think that equals 0. So if it's empty and it was unhidden, so it was is hidden equal to false. Okay, hidden is true. Okay, if it's true, so if it's hidden, so it means that these new ones surrounding the already empty, it was also an empty one and it was hidden. So in this case, we unhide it and we call again this one, position -1, only in this situation. So not only it was hidden, no. This is the conditions only to do it recursively. If not, just unhide. Okay, so this code is the same for all of them. So I think what we can create, this one is just to create another method here, private void clear in position. So just only one, and more or less it will use this code. Okay, so it will say, okay, instead of -1 is just position. So if we, okay, instead of clear, just unhide. So if we want to, I think unhide is already in use, so I cannot use the same name. No, it can be used. Okay, if we want to unhide one position, what we check is that if the nearby mines is 0, so it means that we are empty, and it was hidden, so we want to do it the same, clear the area the same for this position, and of course we want to hide it. So this method is what we will use for any of these ones. So instead of unhide directly, we will use this new method because maybe we need to recursively call again and again. Okay, so okay, it's the same. I need to change it. Mhm. And the lower role, so the position is used, but right now it's a parameter of the new unhide method. See you. Okay, so this one unhide here. Okay, and the last one. Okay, I think that all is done, so let's check. Let's clear this one. Let's run it again. Okay, so the problem is here is that we need to find. Okay, and we have filled the heap. Stack Overflow. So in some way we have called it back. So if get nearby equals to 0, and is hidden true. Okay, I think that I need to hide this to do this before. Okay. Okay, out of hide. Oh, a typo here. It was a -1 already left there. So this is the issues of copy and paste. Okay, so a surrounding area has been cleared, but it's not enough because it's not enough. Okay, okay, I have. Okay, so when I have selected this one, when I have selected the corner, it has cleared the surrounding one. So when it has selected this one, so I try to clear, for example, this, the right one. But the right one, it has 0 mines and it's hidden, it's true. No, it's hidden, it's true, no, because I have added this just above. It must be here. It must be here, and it must be. It must be. Okay, let's add twice because. Again, let's try it. Okay, it works. Now it works. So great, great. We have selected the 0.0, 0, 0 row, 0 column, and it has cleared almost all the positions that can be revealed. So here, of course, we have a mine, and here, yeah, we suppose that is the top one, and the lower one is not. So this is the 0, 1, 2, 3, 4, 5, 6. So this is row 6. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this 10, it must be empty. Okay, so in the middle, of course, we have a bomb. In the same way here, I don't know if you can see it correctly. And this is a bomb because there are a lot of ones. So this one is because this is a bomb. So this is not a bomb. So 0, 1, 2, 3. So it's 3. 0, 1, 2, 3. And the row is the number of rows. So it was 20. So it's 19. 19. Okay, what's doing it? All right. Okay, so it's another one. So that means that all these ones are not bombs. So 4, 19 is not a bomb, and it's clearing more space. So of course this is a bomb, this is a bomb, and this is not a bomb. So how many bombs here? It's only 5. 1, 2, 3, 4, 5. So this is 0, 0, 1, 2, 3, 4, 5, 6. So it's 6, comma 0, 1. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so we have solved it but we don't have the conditions just for the win condition. So the win condition is if you click on a bomb, you lose the game. So only if the remaining unhidden cells are the same as the bomb. So it's like in this situation. So there are 5 unhidden cells, and we have 5 bombs in the game. So this is the condition for the win condition. So in the loop here, we need to add after the check. So okay, this is the hide more than a check. This is a try, a play. So just it's your turn. So it's your turn. So after that, we need to check the win condition on the win and the lose. So both. Okay. So one is very easy. So if the unhide, so just checking this row, this cell, if it was a bomb, so it's you have to lose. So okay, so because we have not, this is not. I mean, so the game, so the graphical representation cannot have any logic. We cannot, I don't want to add here any logic. So here what we can do is just check condition. Okay, it could be check. We can use an internal state to say, okay, whenever you select a bomb, the state of the game change to lose. So we can check that one, but for the winning condition is it's remaining is the same as so not sure it's easier just to do the checking just to check the state, so it could be just logic is game over, so it's game over. It could be just to say okay, okay, logic is a win, is a win. So these two functions could be added using internal states and calculating every time that we select. So so let's add them using an internal state. So okay, let's add that way the moment. So create method and create another one. Okay, so imagine that they are working, so it's not game over. So it's bye bye because you have lost the game. You don't want to continue. So if logic is game over, so say okay, say game over and just exit. Okay. Why it's not okay? It's not expecting a boolean. Okay, change the problem. So the same here. If logic is win, just say you win. Okay, for example, you win and another system exit 0. Okay, those are the conditions. So we need to change the return time. Okay, okay. So the mine finder it's completed the logic for the main uh, for the main for the mine finder. So what we need to create is this one. So let's add some internal state for the logic. So let's say that we have private, okay, I think private logic state, state. Okay, so we will add this new, it will be an enum class. So here add new enum class enum. It will be called logic state. And logic states has different ones. So initial. So maybe running. It will be win or lost. Okay, three different options. So the logic when we create this one, when we create a new map, so we change the internal state. So this state equals logic state dot running. Okay, so that way this logic is very simple. So it's just to return if okay, we can say return if this state equal logic state lost. Okay, if that's true, you have lost. And for the win, it's more or less the same, but we check with the win state. So what we need is someone that change these states. So when we need to change them, so we need to change them every time that we do another turn. So so let's add here just to separate some code. So these are the okay. I think that we have methods and actions here all mixed, but I will refactor later. Okay, so we need to change the state. So when we change the state, whenever the player tries again, so when we click logic unhide, the logic unhide is like the next turn, so it's whenever it plays again, so it's another round. So here in the unhide, what we have done is that we just clear all whatever is needed. So here we need to check the conditions. So change state. Okay, change state. Okay, so change state, and I will provide the row and column. Why? Because this is the easiest way to check if I have selected a bomb. So if this map, the same again, I think I need to create a method just to provide the index. If this call row times in these columns dot is mine, is fits a mine, if that is true, if this is true, we change the state change to logic state dot lost or game over lost. Okay, and in order to check the winning condition is a bit different, so there is an else. So if you have not selected, so what we need to check is the remaining, just to calculate the remaining unhidden cells. So if remaining remaining hidden, okay, like hidden, so they are already, if remaining hidden cells equals to this dot the number of mines, new map, number of mines. We have not saved this one in a local property. Okay, let's add it. Okay, add it, a new field. Okay, above, this is related with the map. This is not related, so okay. If this dot number of mines, okay, if the remaining, then we will change the state as logic state dot win. Okay, so we need to implement this one. So create method remaining hidden cells. So okay, it could be, there are better ways, so we can track the number of hidden cells each time, or we can just do a while loop. So for integer I equals 0 I minus this dot map dot length e plus plus. Okay, this is a while loop. So in remaining equals 0. So return remaining. So if this map, this position, I is the position, so okay. And this is the cell, so dot is hidden is false, so it's hidden. No, if it's true, if it's hidden, then increment the remaining. So if it's hidden, increment it. Okay, so I think we have the code. So let's do it very fast. So let's prepare a very easy one. So just with 3 bombs, 3 mines. So let's start with 0, 0. You win. Something is wrong here. How can you say that I have win? Is hidden. You need to check with the number of bombs. So remaining hidden if it's number of mines, if remaining hidden cells equal this number of mines, and this number of mines is number of mines. Are you cheating? Why? Okay, let's do again. There is something, guys, I cannot catch it. Okay, no, not here. Continue. Continue. 0.0. Okay. Number of mines, 3. Remaining cells, I don't know. So let's go in. Remaining is 0. If this map I, y is hidden, must be true, is hidden. All of them are hidden. Why I'm not increasing it? Is hidden, is hidden. Return hidden. Hidden is true. By default is true. Okay, let's do it again. But hidden, false. Why false? Okay, I think that I have missed something. I have do something wrong at some point. Okay, let's check when I initialize all of them. So when I create new map, create empty map, creates empty map, creates new cells, create is this hidden true. Hmm, okay, this hidden true. Ah, okay. I think it's working. The the problem is that it's not okay. So is the map if very it's very easy. Just clicking, you win because it's all the map is rebuilt. So let's add here after the you win, just add just print the map again. So let's draw the map after those conditions before. Just draw here and draw here. Okay, so let's say so we click this one, and of course we have almost win. So, but in some situations you can win only with one movement. So this is row 0 is 0, 1, 2, 3, 4, 5. So it's 5. Okay, and the remaining is 0 also. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15. Okay, and you win. Okay, so it was working. So it's that in some situations you win with only one movement because it's very easy. Uh, so let's do it again. So let's try again. So just find this situation. Okay, not yet. Another one. You win. So you can win if they are not depending in which positions are. You can win only with just one movement because it's very easy. With one movement, it's clear, and the bombs are surrounded, so they are not related. So there is no issue. So it's easy. Okay, so I think it's working. So it's ready. I think that we have. Of course, we will need to change part of the logic later because always when we move this to the graphical with events, so we will need maybe to do some changes here to the interface or the public functions that we use, but we will not use this draw map. But we have our um, console a text version of the MineFinder, the MineSweeper. So mainly what we use from the logic that is doing the game is that we use just we need to create a new map. We need to draw the map. Not exactly what we need is to get the char array, just to get the type. So something that the drawing system knows how to draw it, the types. Unhide, this is just to do a play. So play, so just to select one of them instead of doing it using the input from the console, we will use the mouse. And we will of course check the condition if you have gain, if you have win, or if you have fail and it's a game over. Okay, so I think it's very easy. It's working. So let's do a last one, adding some more with 5. Okay, so more or less we have 3 of these ones. So of course this is one of them, and this is one of them. So these two must be clear. So 0, 1, 2, 3, 4, 4, 0, 1, 2, 0, 1, 2, 3, 4. So 4, 3, and 4, 4, and you win. And let's try again, but with trying to lose. So let's select this one. For example, this is a bomb. 0, 1, 2, 3, 4, 5, 6. So 0, 6. Game over because I have selected a bomb here. Okay, so it's working. Maybe okay. So for the game over, usually it reveals the whole map, and so and just highlight the bomb that you have selected. So maybe we need something about. We need to check. We need to get the last movement or the last position that has been changed. So okay, there are some functions, some methods, or some things changes that you need to change when 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 you move from text to graphical interface. So okay, so all is working. So I think it's time to mark it that new console game Minefinder is working. So that was what we wanted to complete today. So happy another good live coding session. So okay, see you tomorrow, and have a nice rest of the day. See you. Bye bye.